In this example, we're going to solve this linear system by elimination. So the first thing we're going to make sure of is that each of our equations is in standard form. So it needs to be x and y on the left side and the constant on the right side. So I have 3x equals, so this 7y needs to come over. So we'll end up being a negative 7y, and that will equal our negative 23 that's already on the right side. And the second equation, this positive 16 needs to go over to the right side. And he'll do so, and he'll be a negative 16. Okay, so now we're ready for our elimination process. So we need to choose between our x's and y's which one we're going to eliminate. It looks like our x's are both positive, our y's are both negative, so I know that whatever I multiply by, one of these is going to have to be negative, because the signs have to be opposite. And 2 and 3, well, 2 and 3 aren't factors of one another, and 5 and 7, they don't really work well either. So I know I'm going to end up multiplying both equations. So let's bring the 2 up here, and the 3 down here. Let's go ahead and make that 2 negative. So when I distribute through here, the negative 2 is going to end up being a negative 6x plus 14y equals positive 46. And the 3 will be a 6x minus 15y equals negative 48. Okay, you'll notice that the deal here with the 2's and 3's, how I just flipped them. So 2 times 3 was 6, and 3 times 2 is 6. And we included this negative sign so they would cancel out when I add the two equations together. So 14y minus 15y will be a negative y equals negative 2, because 46 minus 48. So then y will equal a positive 2. Okay, once I have the value for that variable, I can go ahead and plug them in. So let's go ahead and plug them back into the first equation. So I have 3x equals 7y, and y was 2, and then minus 23. So 3x equals 14 minus 23. 3x equals negative 9, so when I divide both sides by 3, x equals negative 3. So now that I have both values, I'm going to go ahead and write my solution as an ordered pair. My x value comes first, and then my y value. So I have this ordered pair, negative 3, 2, and this is the solution for this linear system.